Hello everyone. Previous lecture we have studied the concept related with the chapter Conics, and in that we see some various example depend on the part here parabola. Now in today's lecture we go with the new concept in this chapter, and for the parabola here tangent at a point on a parabola. That is, here we have to consider tangent related with the parabola. Here to define the tangent, we consider one figure. Here we consider one line. Suppose this line is L. This line touches the parabola at point P. Remember, here we consider only one point, and this line touches the given parabola at point P. Since this line touches only in one point to the given parabola, this line is called tangent, and this is the tangent of the given parabola. Okay, so a straight line which intersect the parabola in one point, then this line is called tangent of the parabola. Okay, so in this lecture we have to see, or we have to define the equation of the tangent. Here to define the equation, we consider equation of parabola. Here is y square is equal to 4ax. Since line passing through the point x1, y1, point P having coordinates x1, y1, then here equation of tangent is always in the form y1 equal to 2a into x plus x1. Okay, so here I write the equation of tangent to the parabola y square is equal to 4ax. This is our parabola. Okay, at point P of x1 y1 is, here is y1 is equal to 2a into bracket x plus x1, and this is the equation of the tangent. This is the equation of the tangent. Directly we consider one point on the line or on the tangent. We consider equation of the parabola, and we define this type of equation, and is here equation of tangent. Suppose in point P, if we have a parameter T1, in point P we consider parameter T1. That is, here we consider coordinates of P as here at square, then twice at. Here we use T1 to define the parameter. Okay, so 81 square comma 281 are the coordinates of the point P. And if we have equation of parabola as y square is equal to 4ax, then the equation of tangent to the parabola y square is equal to 4ax at point P is, here at1 is equal to x plus, okay, here we consider yt1 is equal to x plus at1 square, and this is also equation of tangent to the given parabola. Here remember we consider parameter T1, so this is equation of tangent in the form of parameter T1. So these two equations are very important and to define the equation of tangent. Let's go with our next important part, or we have to define here condition of tangency now. Okay, so we go with this part, condition of tangency. Condition of tangency. Okay, here we consider one line. The line is here y is equal to mx plus c. Then we consider equation of the parabola. Suppose here parabola is the equation of parabola is y square is equal to 4ax. Now the condition for the line who touches the equation y square is equal to 4ax, that is for the equation of tangent, here condition is c is equal to a by m. That is, this line is a tangent to the given parabola y square is equal to 4ax. Here is c is equal to a by m. C is equal to a by m. So remember this condition of the tangency. Here c is equal to a by m. Now here we go with next definition, and in that we have to define the equation of the tangent in the form of slope. Okay, so here in next, the equation of tangent, in terms of slope m, here is y is equal to mx plus we use c. Here we know condition for tangency, here is c is equal to a by m, so we replace this c by using a by m, and here we get y is equal to mx plus c is a by m. So this is the equation of the tangent in the form of slope m. So remember this equation also. So in today's lecture, we have to see some important examples related with these concepts. Let's go with our first example. Here given, find the equation of tangent. Find the equation of tangent to the parabola y square is equal to 9x at point 1 minus 3. Okay, now here we have to find the equation of tangent, and for this given equation of parabola is y square is equal to 9x. Okay, so we define given things first. Given here y square is equal to 9x. Here everyone knows this is in the form, or this equation is of the form y square is equal to 4ax. So we compare this equation with our standard parabola y square is equal to 4x. Comparing this equation with y square is equal to 4ax, then we get, if we compare these two, here we get 4a is equal to 9. That is, here we get a is equal to 9 by 4. Firstly, we get value of a. Okay, now here everyone knows the equation of tangent to the parabola y square is equal to 4ax at point p of x1 y1. Here always y1 equal to 2a into x plus x1. Okay, so we use this equation. Here I write, we know we know the equation of tangent to the parabola y square is equal to 4ax at point P of x1 y1 is equation is y1 equal to 2a into bracket x plus x1. Okay, now here we know this a, here a is 9/4. Here x1, y1 are the coordinates of P or are the coordinates of given point. Here given point is having coordinates 1, -3. Here x1 is 1 and y1 is -3. So we replace all these things in this equation. Here y into y1. y1 is -3 equal to 2 into a. A is 9/4. Then inside the bracket x plus x1. Here x1 is 1. If we solve this part, here we get -3y is equal to, we know 2/4 is 1/2. Here we have 9/2 inside the bracket x plus 1. Now we multiply both the sides by 2. If we multiply, here we get -6y is equal to 9 into bracket x plus 1. Let's multiply this given bracket by 9. If we multiply, we get here -6y as it is. Then in RHS, 9x plus 9. Okay, then in next step, I write this as here 9x plus 6y plus 9 is equal to 0. Here we take 3 as common. Okay, then 3 into bracket 3x plus 2y plus 3 is equal to 0. Let's divide both the sides by 3. Then we get here 3x plus 2y plus 3 is equal to 0. And this is the required equation of the tangent. This is required equation of tangent. So very simple example it is, directly by using our equation y1 equal to 2a into bracket x plus x1, we find equation of tangent. Let's go with our second example. Here in second, given, find the equation of tangent. Find the equation of tangent to the parabola y square is equal to 12x from the point 2, 5. From the point 2, 5. Okay, here again in this example we have to find equation of tangent, and for this equation of parabola is given. Here is y square is equal to 12x. Here also given tangent is from the point 2, 5. Okay, so here by using the equation of tangent in terms of slope, we find equation of tangent. Okay, so firstly we consider given equation of parabola. Given y square is equal to 12x. Let's compare this equation with y square is equal to 4ax. Comparing given equation with y square is equal to 4ax, we get Here we get 4a is equal to 12. So here we get a is equal to 3. We get value of a as 3. Let m be the slope of given line. Okay, so here I write let m be the slope of the tangent drawn from the point to 5. Now here everyone knows the equation of tangent in terms of slope, and is here y is equal to mx plus a by m. Okay, therefore the equation of tangent in terms of slope here is y is equal to mx plus c by a by m. Mx is equal to a by m. Now here we know a is 3, so we replace a by using 3 in this equation. We get y is equal to mx plus 3 by m. Now here we know our tangent passes through the point to 5. Okay, so here I write it passes through point to 5. Okay, so we replace x by using 2 and y by using 5 in this equation. Then we get 5 is equal to m into x. Here x is 2 plus we know a is 3, so 3 by m. Let's solve this equation or this expression. If we solve, here we get 5 is equal to 2m plus 3 by m. Then here we get 5 is equal to 2m square plus 3 upon m. Let's multiply both the sides by m. Then we get here 5m is equal to 2m square plus 3. Okay, and in last we get here 2m square minus 5m plus 3 is equal to 0. We get here quadratic equation. And this is quadratic equation in m. So it has two roots. This equation has two roots. Let m1 and m2 be the two roots of the given equation. Okay, so here firstly we solve this equation. Here we get 2m square minus 3m minus 2m plus 3 is equal to 0. Okay, therefore here we keep m as common, then inside the bracket twice m minus 3. Here we keep minus 1 as common, so minus 1 into bracket twice m minus 3 is equal to 0. Okay, then here we get twice m minus 3 into m minus 1 is equal to 0. Okay, therefore here we get twice m minus 3 is equal to 0, or m minus 1 is equal to 0. And in last we get here m is equal to 3 by 2 and here m is equal to 1. Okay, so we get two roots. Okay, and these two are slopes of the tangent. Now we replace this m in this first equation to get the equation of tangent. Okay, so in next step we consider our first point, this first point. So from from 1. If m is equal to 3 by 2, then, okay, here we replace m by using 3 by 2. So we get y is equal to 3 by 2x plus here 3 upon 3 by 2. If we solve this expression, here we get y is equal to 3 by 2x, then plus 2 only. Then in next here y is equal to 3x plus 4 upon 2. And in last here twice y is equal to 3x plus 4. Okay, and in last here 3x minus 2y plus 4 is equal to 0. This is the first equation of tangent, and this tangent passing through the point 2, 5. Now here our second value of m is 1. Now we replace this m is equal to 1 in this first equation. Okay, so again from 1 here we consider m is equal to 1. Then here 1 is y is equal to 1 into x plus here a upon a is 3, so 3 upon 1. Therefore here y is equal to x plus 3, and in last here x minus y plus 3 is equal to 0. Okay, so this is our second equation of the tangent. So we get here two tangents. First is 3x minus 2y plus 4 equal to 0, and second is x minus y plus 3 is equal to 0. So these are the required equation of the tangents. Okay, so again very simple example, it is directly by using the form of equation of tangent in terms of slope we find these equations. Let's go with our third example. Here in third given, if the tangent drawn from the point minus 6, 9 to the parabola y square is equal to kx are perpendicular to each other, then find k. Okay, here again equation of parabola is y square is equal to kx. Here k is given. Okay, our tangent passes through the point here minus 6, 9. Here also given tangents are perpendicular to each other. Okay, so we consider our given equation of parabola first. Given y square is equal to kx. Let's compare this equation with y square is equal to 4ax. Comparing given equation with y square is equal to 4ax, then we get here 4a is equal to k. Here then we get a is equal to k by 4. Firstly we get value of k, and here is k by 4. Now here we consider m. Here m is the slope of tangent. Since here given tangents are perpendicular to each other, we consider slope of the tangents. Okay, let m be the slope of tangent drawn from point, here point is given, minus 6, 9, minus 6, 9. Okay, now we consider the equation of the tangent in terms of slope. Okay, therefore its equation is, here is y is equal to mx plus a by m. We know a is k by 4, so we replace a by using k by 4. So y is equal to mx, here is k by 4 upon m. Then here we get y is equal to m square x plus k by 4 upon m. Okay, or we write this part as, firstly y is equal to mx plus k by 4m, like this. If we solve this expression, we get y is equal to 4m square, then 4m square x plus k upon 4m. In next step, we get here 4m y equal to 4my is equal to 4m square x plus k, 4m square x plus a. Okay, then here we get 4m square x minus 4my plus k is equal to 0. Since our tangent passes through the point minus 6, 9, we replace here x by using minus 6 and y by using 9. Okay, so we get here 4 into m square. X is a minus 6 minus 4m into y. Y is a 9 plus k is equal to 0. We know 4 into minus 6 is minus 24. So minus 24m square. We know 4 into 9 is 36. So 36 minus 36m plus k is equal to 0. We apply minus sign on both the sides. We get 24m square plus 36m minus k is equal to 0. Now here we get quadratic equation in m. So it has two roots. Let m1 and m2 be the roots of the given equation. These two are the roots, means here m1 and m2 are the slopes of the tangent. Okay, let m1 and m2 be the slopes of tangent. Okay. Here also given, here tangents are perpendicular to each other. Since tangents are perpendicular to each other, here we consider m1, m2, that is product in between the slopes. Since tangents are perpendicular to each other, here product in between their slopes is always minus 1. Therefore, here I write, we know this m1 into m2, that is product in between m1 and m2. m1, m2 here is constant upon coefficient of m square. Okay, so here constant is minus k, this divided by coefficient of m square is 24 and is equal to minus 1. Here I repeat, this m1, m2 is constant upon coefficient of m square, that is here minus k upon 24. So this implies here k is equal to 24. So here we find the value of m, and here value of k, and here is 24. Again, directly by using the equation of tangent in terms of slope, we find the value of k. So in today's lecture, we define tangents. We define the tangent at a point on the parabola. Then we see the condition of tangency. We define the equation of tangent in terms of slope. Here is y is equal to mx plus a by m. And we see some important examples related with these parts. Thank you.